So now we're at the sixth question. Okay, so a rectangular tank is 90 cm long and 30 cm wide. The height of the water in the tank is 36 cm, and 21 liters 600 milliliters of water are poured into the tank to fill up to its brim. So what is the height of the tank? Okay, so let's find the height of how much they poured in. Okay, so we find this part. To find the height of the water added in, okay, we first take the volume that was added in, which is 21 liters 600 milliliters, and we divided it by the length of the cuboid, the tank, and we divide it by the breadth, which is this part, 30 cm. Okay, so that we can find the height, this part. Okay, so I'll take 21 600 divide by 90 divide by 30, and that will give me 8 cm. Okay, so we know that this part is 8 cm. Okay, and to find the height of the tank, I'll just take 8 cm plus the original water level, which is 36 cm. Okay, and that will give me 44 cm. So the height of the tank is 44 cm. Now we'll look at the seventh question. Okay, a rectangular tank is 20 cm long, 15 cm wide, and the height is 30 cm. So I'll draw out like a rough diagram first so we can visualize it more properly. Okay, so the rectangular tank is 20 cm long and this 15 cm wide, and the height is 30 cm. Okay, so something like that. Okay. And it is completely filled with water. Okay, but after some time, 1 liter 200 milliliters of water was poured out, and the water dropped to a certain level. So let's just pretend that this part is 1 liter, this part is 1 liter and 200 milliliter. Okay, so this part has missing. Then now we are finding what's the height of this part. Okay, so we first find the volume of the rectangular tank. Okay, so we'll take 20 cm times 15 cm times 30 cm. So 20 times 15 times 30 will give me 9,000 cm cubed. Okay, and we know that 1 liter 200 milliliters were poured out. Okay, so we will find out what's left in the tank. What's the volume left in tank? So we will take 9,000 cm cubed, which is the total of the water level, minus 1200 cm cubed. Okay, so this part, 1 liter 200 milliliters is the same as 1200 cm cubed. Okay, so 9,000 minus 1200 will give me 7,800 cm cubed. So this part is 7,800 cm cubed. Now I want to find the height of this part, which is the water left in the tank. So height of water left in the tank, I will take the volume 7,800 and I divide it by the length 20 cm, divide it by the width 15 cm. Okay, so divide by 20 divide by 15, it will give me 26 cm. Okay, so that is our answer. 26 cm is the height of the water level left in the tank. Okay, let's read the question together. A rectangular tank is 30 cm long, 20 cm wide, and the height is 15 cm, and it's partially filled with water. After additional 1.5 liters of water was poured in, the tank was completely filled. What was the height of the water in the tank at first? Okay, so height of the water means this part. What is this part? Okay, so we first start off with this part. 1.5 liters is equal to 1,500 milliliters. Okay, and then it after adding this amount, water is completely filled. So let's find the height of how much they add in. Okay, so this part. Okay, so I will take 1,500 milliliters and I divide it by the length, which is 30 cm, and I divide it by the width, which is 20 cm. Okay, so 1,500 divided by 30 divided by 20 will give me 2.5 cm. Okay, and then to find out 2.5 cm is how much they added in. Okay, this part. Okay, so our original is 15 cm, and to find this part, the original height of the water in the tank, I minus it by 2.5 cm. Okay, so 15 minus 2.5 is 12.5 cm. Okay, so the height of the water in the tank at first is 12.5 cm. Okay, let's read question 9 together. So a container with a square base of side 30 cm is 3/4 filled with water. Okay, so I'll just draw out a rough diagram for y'all to see. Okay, so this is my container, and then the side, the square base, and the side is 30 cm, 30 cm. Okay, and this 3/4 filled water, so we estimate 3/4, like let's say here. Okay, and when 10.8 liters of water is poured out, the water level drops to 3/8. So to visualize this better, right, 3/4, 3/8. Okay, 3/4 is equals to 6/8. Okay, 3/4 equals to 6/8 times 2 times 2. Okay, so 6/8, and then after that it will drop to 3/8. So I'll draw, like, let's say 3/8 is around here. Okay, so this is the water level that is like left inside at the very end. Okay, and then 10.8 liters pour out, so meaning this is 10.8 liters, which is this part which is poured out. Okay, so find the height of the container. So first we find the height of this part, 10.8. Okay, and to do that, we first do this. 10.8 liters is equals to 10,800 milliliter. Okay, and then after that we divide it by 30 cm to find the height. So to find the height, it equals to 10,800 milliliters divided by 30 cm divided by 30 cm. 10,800 divided by 30 divided by 30 give me 12 cm. Okay, so the height, this part is 12 cm. And we know that 12 cm, right, it is when 6/8 minus 3/8, which is 3/8. Okay, so 3 units equals to 12 cm. This part is 3 units. Okay, and you want to find the height of the container, which is 8 units. Okay, so 1 unit equals to 12 cm divided by 3, give you 4 cm. And 8 units equals to 4 cm times 8, which gives you 32 cm. So the height of the container is 32 cm. Okay, now we're at the last question already. So the water level of a sealed container is 18 cm. What is the height of the water level when a sealed container is turned to its side as shown? Assume no leakage of water. Okay, so I'm gonna transfer the cm, the dimensions, into this box. Okay, but let me just show you. Imagine that this part is the length of the box. So this part is 20 cm over here, the length of the box. When I flip it this side, right, this will become the height of the box. So this part, the height is 20 cm. Okay, and then after that, this part will also be 20 cm. And then this part, the length is this one. So if I flip it this way, it goes like that, right? So this is this. Okay, so it is 18 plus 18, which will be 36 cm. Okay, so this part is this part, which is 36 cm. Okay, so now we will find the volume of the water that's inside this container. So volume of water equals to length times space times height. Okay, so I'll take 20 cm times 20 cm times height, which is 18 cm. Okay, so 20 times 20 times 18, and that will be 7200 cm cube. Okay, and now we are trying to find what is the height of the water level. So assuming that I have some water in here, okay, and then after I flip it this side, the whole height will change also, right? So let's say it will be like around, let's say somewhere here. It's just an estimate, okay? So what we're trying to find is the height of the water level into this container, this part. This is what we're trying to find. Okay, so to find height, I will take the volume, which is 7200 cm cubed, and I divide it by 20 cm. I divide it by 36 cm. And that will give me 10 cm. Okay, so this part is 10 cm. So the height is 10 cm when it's turned to its side.